Proportions can be a little confusing, so I'm going to do my best to explain how to solve these problems, and I'll try to make it make as much sense as I possibly can. So a proportion is typically some kind of rate, and for these problems, that's all we're dealing with. Now, a rate you can think of as something like miles per hour, where we have 1 unit on top and 1 unit at the bottom of a fraction. If we look at this first problem, it says suppose that 11 inches of wire costs 66 cents. We can turn the sentence into some kind of rate. We can either write it as 11 inches for every 66 cents, or we can write it the other way around as 66 cents for every 11 inches. Now, there is a right and wrong way of doing this, but our options are to choose between one of these two ways of writing that ratio. So the way we pick which one of these we want to use is that we look at what the problem is asking us for. In this case, they're asking us for how many inches of wire, and they give us 36 cents. So what we're going to do is we're going to take one of these two fractions, and we're going to multiply them by 36 cents. Now, one of these would end up giving us the correct results. It will end up giving us inches, which is what we want. But the other one would not end up giving us inches as our unit. So if we look at this first example, and again, at this point, we don't know which one is correct. We don't know if the first setup is correct, or we don't know if the second one is correct. But if we look at this first example, and if we only look at the units, so forget about the numbers, just look at the units. We have inches over cents times cents. If we do the math, what will end up happening is the cents would end up crossing out because we have cents at the bottom of a fraction and kind of on top of a fraction. Even though this isn't a fraction, you can think of it as being over 1. So the cents would cross out and it would leave us an answer that has the units in inches because that's the only thing left. That's the only unit left in this entire problem. Now for this bottom example, if we look at the units, we have cents over inches times cents. In a way, both of these cents are numerators. You can think of this cents as being over 1. So this would actually give us cents times cents as a unit, and it would give us cents squared, which looks really, really weird. But cents squared would be in our numerator of our answer, and in our denominator, if we look at the units, we only have inches, so we would get an answer that's in cents squared over inches. And that's not what we want because our problem is asking us for inches. So we're not going to do it the second way. Now for some problems that is what we want, but for this particular problem, we're only going for inches, so we want cents to cancel out. So we know that this is our setup because there's a cent at the bottom and a cent at the top of the fraction, and they cancel each other out to leave us with inches as our only unit for our answer, and that's what the problem is asking us for. How many inches of wire can be bought for 36 cents? The only thing left is to do the math. And even though you can't see it in the screenshot, I do believe this problem allows you to use a calculator. So that's what I'm going to do. On a calculator, I'm going to type in 11 divided by 66. And then I'm going to take that result and multiply it by 36. And my answer would be 6 inches. So we would get 6 inches as our answer to this problem. So this problem tells us that Christine drove 504 miles in 8 hours. So I made this into a rate. I made it into a fraction. Now I don't know if we're going to use this or if we're going to flip it around because it's entirely possible that we have 8 hours divided by 504 miles. To determine which one we want to use, we look back at the problem and the problem asks us how many miles would she drive in 5 hours. So they give us 5 hours, which means that we want to cancel one of these out with 5 hours. If I multiply the top one by 5 hours, then we have an hours on the denominator and in the numerator, so they would cancel out and they would leave me with an answer in miles because miles is the only unit left. And that's what we want. We want how many miles would she drive in 5 hours. So we're going to stick with this first ratio that I wrote down, which is this entire expression. If I would have done it at the bottom, the hours would not cross out because technically these hours are in the numerators and it would leave me with hours squared over miles, which makes no sense, at least not for this problem. So we just ignore it. So going back to this first expression, the only thing left is to do the math or use the calculator to do the math for us. So we have 504 divided by 8. That's 63, and then we multiply it by 5 and we get 315. So our final answer ends up being 315 miles. For this last example, we have 238, and even though it originally has a dollar sign written off to the left, I'm going to write the words dollars because it's a little easier to work with. So we have $238 for 17 hours of work. So our proportion that we would end up using is either this proportion or this other proportion where the units are flipped. So $238 would go at the bottom. The way to figure out which one we use is by reading the rest of the problem. The problem says, at the same rate, how many hours, so we're looking for hours, would he have to work to make $168? So if we're looking for hours, that means we want to cancel out the dollars. If we look at our first expression and we multiply it by $168, would the dollars cancel out? No, because this dollars is technically over 1. And we would get dollars times dollars, which is dollars squared. And that is not what we're looking for as a unit for our answer. So we're not looking for dollars squared per hour, so we're not going to be using this first expression. Instead, we're going to be using this one. So now we're going to multiply this by $168, and we're going to look at the units. So after I set it up, if I look at where the dollars are, there's the dollars in the denominator and there's the dollars in the numerator, if we think of it as being over 1. So these dollars are going to cancel out. And it'll leave us with a unit in hours, which is exactly what the problem is asking us for. The only thing left is to do the actual math. We need to take 17 divided by 238 and multiply it by 168. When we do that, we end up getting the answer of 12 hours, which would be the final answer for the problem.